Alrighty, well here I have another function that actually calls two functions. So this is what we call Newton's method, and it's a way to attempt to find zeros of functions. We say attempt because I'll probably give you some in homework that don't work, just to kind of show you that it doesn't work all the time. But we have these two functions. One function is defining the function we want to have zeroed. Okay, we want to find the zero of, say, this quadratic function here. Then this other function finds the slope at a point x, or at x value, and then a very close by point x. It determines the slope there. So we're going to use a delta x really, of 0.01, and we're going to look at x and then x minus that 0.01. And so we'll get the rise over the run, but the run's just delta, so we'll get the slope here, rise over delta. So we'll get those two slopes, and then we're going to use them here in Newton's method to print out a series of x and f values that hopefully get us close to our zero. And now, so I print out a bunch just so you can see Newton's method at work. And you know, we'll get that made, you know, for you that way. But then actually down here where we call the function, so notice this function returns two values. It takes two values and returns two values. And notice that the x that comes in actually gets changed. And so you know, we print that out. Now, before I print it out, let's go here and kind of see what's going on. So here I have that function, x squared minus 4x minus 2, starting point at 7. And so here you see I find that slope, and the slope is 10 at around x0 equals 7. So here I've got an equation for that line that has a slope of 9.99 and goes through the point 7 and f of 7, which is f of 7 is a little less than 15. It's 14 point something. Okay, so if I click on that, then there's that line. And here are actually 2 points. So you see the 6.99. Well, oh, there it was, 7. Oh, 7 and 19. Oh, I'm not very good at numbers, I guess. Anyway, so yeah, it's 7 and 19, and 6.99 and 18.9. Well, we find the slope there, which was 9.99. We draw that line, and it has a 0 here at 5.098. Well, how would I find that 0? Well, look here. I would let y equal 0, and then I would bring the f of x0 over to the left-hand side here, and that would make it negative. Oh, there's a negative right here, and f at x0. Then I would divide both sides by m0 to just get x minus x0 here. And so there's divided by m0. And then I would have x minus x0, and I would just bring that over to the left-hand side. And I would have x equal x0 minus f at x0 over m0. Well, I'm going to call that x1 and get that point and go straight up here and do it again. And if I do that again, I get this line. And again, here are my 2 points, actually, very close together. And then they come down, and notice how they're getting very close to where this function up here is actually equal to 0. Now, if I click on that function, I can tell you that function's equal to 0 at 4.449 about. And after these 2 iterations, I'm at, I think, 4.51, I guess. And if I click here, I can see that at 4.516. So I'm really close. Well, so let's look at Newton's method run here. So again, I define the function, I determine the slope at a point nearby any x, and here I just iterate through. I start at my original x value that I give it 7, and I say, well, go through this 9 times and see how we're doing, and then return the value. But I print it out each time just so we can see the progress, and then I print it out at the end. So I'll click here and run. And so there's our 7 and 19 that we started with. Here's our 5.09, but we were up at 3.598. Then here's our 4.516. So these are the numbers we saw back here. See, there's our 5.098. And then x2 is 4.516, so we get those same numbers. But it keeps going, and we get down to 0.003. We get down to a y value of -7 times 10 to the -6th, then 10 to the -8th, then 10 to the -11th, 10 to the -14th. These are getting very small. And then we get 0. And of course, once we hit 0, it doesn't change. And so we got 4.449489, and so rounded to 3 decimal places, it is exactly what Desmos said we get if we just click on their 0 for it. Okay, so I don't know what their next decimal place would be, but we're definitely very, very close. Okay, so that is a definitely more complicated use of functions, but it's a nice one that we can do for a pre-calculus sort of thing. If you've had, pre-calculus, calculus, you can do it where to get the slope you can use the derivative, but if we've only had pre-calculus, we don't know that yet. And so even college algebra, you can do this. You can talk about this method because we're just, we're approximating the slope there with 2 points really close together, and that's a pretty nice algorithm, and works pretty well. But again, it doesn't always work, and I'll give you some homework to see that it doesn't always work. All right, so there's Newton's method.